So this first section on our review, this is a retake opportunity for everybody, and we are going to change the first couple problems. So if you haven't already done so, please see the changes that I made to 1A and 1B. So that way they are more reflective of what you're going to see in your summative. So we have a population of 626,000 people. It's going to increase 2% per year. Determine what the population of that city, when the population will hit 1 million. That was supposed to say when it will hit 1 million. So the formula that you're going to be given on your test looks like this, but you have to know how to use it. So in this problem, the A value, that's our original amount. Who's the original amount in this problem? 626,000. Good. And then we're not going to both add and subtract the rate. You have to make a decision. Are we adding or subtracting? We are increasing, so we are adding. Yes, you heard that right, sub-adding. Yes. Adding 2%. How do you write 2%? 0.02. Good. Now, because we changed the problem from the original one, it now says, when will your population hit 1 million? They don't give me time. That's what I'm trying to find, so we're going to leave that as a variable, which means we're going to be using our table. So type this equation into Y1, and then you're going to go to your table and look to see when the Y values roughly get to 1 million. So you can tell me between so many years, or if it's closer to one than the other, just say about this many years. But we're going to pause for our friends to type that in. So I'm hearing from our friends that it's 23 to 24 years. All right, so 1B is a very similar question. This time it's with an isotope, but the same idea. I think you guys might want to practice that, judging from our last couple of minutes here. All right, moving along to number 2. Yes. Yeah, so like after it should say an E. Is there like an E? Oh, for 1B? Yeah, let's set up the equation together. So the original amount is 659.3. And then are you adding or subtracting the rate? Subtracting, good. So 1.3%. If you're not sure exactly what the decimal looks like, you can always divide it by 100, but yes, it's 0.013 to the x power. And this time you're looking for the table to hit 500, so shouldn't take too long. Okay, now we're moving on to number 2. Number 2, you're going to be given this formula to use. You just have to know how to use it. Last time we tested this, some of you had a real tough time figuring out what the n was versus what the t was, and you were confusing them. So can someone talk to me about what n represents? It's the number of times that you collect interest. Yep. So there's some word here that tells me how many times a year I'm going to get interest. And that's the compounded quarterly part. That's the n, guys. So how many times a year are you getting interest if it's every quarter? It's 4 times a year. So what I would suggest you do as you go through the problem and you're reading it, just put little notes to yourself above the numbers, like this is our initial principal, and then this is the rate. But you might want to make a note here, guys, because a few of you put like 2.5 in your formula. Do we put 2.5 in our formula? No, we put 0.025. N is 4. And then if I keep reading, it says balance after 5 years. There's your t. T is 5. So we are going to be on our home screen of our calculator, and we're going to be typing in all this information because there's no more variables left once we have everything plugged in. So 5,200. 1 plus, you guys told me this is 0.025, divided by our quarterly, so that's 4. And then that quarterly number shows up again up here. You don't have, if you're using a yellow calculator, you don't have to have parentheses around the exponent, but if you have an older calculator, you definitely need them. And we're supposed to multiply by how many years, which is 5. So, in your home screen of your calculator, please type this. And it's dollars, so give me dollars and cents as an answer. Okay, I heard a lot of things. Try again. 5,000. 800. and 90. Thank you. Very good. So 2b, I'm not going to do that one with you, but could we point out what the n value is going to be for 2b if it's collected monthly? That means 12. Okay. Quarterly would be 4, monthly would be 12. Those are usually the ones we run into on our tests. Hint, hint. What? Yep, formulas will show up again just like they did last time. All right, number 3. Some of you had a real tough time with this question on the last test. So we have birthday money. It's going to go into an account that collects 2% continuously. So 2%, that means a rate, but we're going to write that as 0.02. Continuously. What does that mean? All the time. So there, we don't, infinity won't work for the formula, so instead what they derived for you is a continuous formula. We're going to be using PERT. The reason it says PERT down here is because of the word continuously. So you're going to be given that. You don't have to memorize that. But you do have to know what all these things represent. So P is your initial principal.
100.
Yep, it could be anything you want. $100 sounds good. So let's invest $100. And then it's our friend E. We've been working a lot with E lately. So we're going to multiply it by the number E. But up in his exponent, you have your rate times time. So 0.02 multiplied by time. Hey guys, we don't know time. So call it X. Good. Again, you don't need the parentheses up here if you have a yellow calculator, but if you have an older one, you do. Hey, we have a variable. Should we be in the home screen or the y equals screen? In the y equals, yep. The other dead giveaway here, guys, it says use your calculator's table to figure it out. So I want my money to triple. What am I looking for? Good. $300 would be triple of our $100. Go to our table. It's pretty, yeah, it takes a while.
Alright, I'm going to have to say 54 and 55.
Are we getting 54 to 55 years? Yeah. We try not to make them go that far out on the table on the test usually, but on the reviews I don't care. I don't care how much time you waste looking through a table. Alright. I think it's plenty nice. Oh, we haven't seen this question on a test yet, but we have done a couple of these in our notes and worksheets. Remember our job offers question? Alright, so we are being offered 2 jobs. Judison. They'll give you a base salary of $35,000 with a $900 annual raise. So Judison's formula is right here. And then Warren will give you a $25,000 salary, and then they'll give you a 7% annual raise. So this is Warren. So straight mathematics of it. A lot of people look at these offers and they're like, well, duh, go with Judison. They're paying you more money. So what do you think about that, Ashley? Yes, so we have to be careful about the time aspect of it. And that's what I'm going to be looking for when I grade this. You can't just be like, well, I know the answer is going to be Judison or Warren or whatever because like last time we did this question, it was the second one. Because that's not actually the answer. The answer is, when are you going to leave this job? So we don't know that answer yet. We got to find that magic point in time where all of a sudden the other job is going to pay you more money. Can someone talk about the math associated with why Warren is going to eventually pay me more money?
Because it's continuously.
Yes, good. A exponential growth raise is going to grow faster. If you think about the way it looks, you know, the curve versus a linear curve. So what we're going to need to do is go to our calculator and get these programmed in. And it's up to you. If you want to look at the table to figure out when the other one overtakes the other, that's fine. If you want to look at the graph, you can, but getting the windows a little tricky. I think for you guys, the table would be the best bet. It is up to you. So I'm going to show you on the graph, though, because I think some of you like to see the picture of it. Go to y equals and program both functions. I'm going to put the first one in the y1 and the second one in y2. That's not it. All right. Was it 3,500 plus 900x? Okay. 1,000 plus 900x? And then, what was Warren?
25,000. And then 1.07.
Mm-hmm. Okay, so before I hit graph, because I'm going to show you what the graphs look like, I want my window set up so it makes sense. So what I'm going to do is I'm going to use a bit of a cheat. I'm going to set up the x's for something appropriate to the problem, and then I'm going to zoom fit. So x represents time that you spend at your job. What would be a good window for how much time you're going to spend working at this place?
45.
But like starting when?
0.
0 to... Oh, okay. So then I don't have to worry about the rest of the window. As long as you set up the x's, you can do zoom fit. So 0 to 25 for x's, and then go to zoom and scroll down to the 10th one, or you can just type a 0, and it will magically fit it for you. There's that linear growth. There's the exponential growth. So zoom and then 0, or you can scroll down to where it says zoom fit. So I can see visually that Warren will eventually overtake Judison, but I got to figure out when that point is. So if you can find the intersection point, you'll have a really nice, easy to find answer. Do you remember how to find intersection points on a graph? Yep, go to the calc menu. This time choose intersect, and then just hit enter 3 times. So enter, enter, enter. And then look at the x value there, guys. At 7.6 years into my job is when the other job starts making more money after that. So as far as your answer goes, you have to give me some words, okay? You got to write some sentences down. Give me an example of an okay answer. There is a blank somewhere on there where it says how many years will the one overtake the other. So that 7.6 years thing, or if you said between 7 and 8 years, that needs to go down there. So what kind of answer you got for me?
If you're working less than 7.5 years, you should work at
Judison would be better if you're not planning on staying after 7 years. Mm-hmm. Yep. And if you're staying long term after 7, 8 years, you want to be there for a long time, Warren will eventually pay more. And the raises will come a lot faster. I mean, if you look at your table, guys, after working there for like 15 years, Warren pays a lot more money. Okay. All right. Questions on that one? We haven't tested that one yet. So, whenever I'm answering word problems for my, word answers for my math teacher, I usually end up writing a lot more than I probably need to, and that's okay. You ever do that in English class? You just keep writing and writing and writing. You're like, something here has to make sense. Just keep writing. Just write something. All right. Oh, that's our new stuff. Yay. Logarithms. Okay. You are going to be both expanding and condensing, okay? I'm going to do the A's here. You're going to do the B's. So we are expanding this logarithm. How many things are in this logarithm? There are 3. Good. There is a 5. There is an a to the 3rd, and there is a b to the 2nd. So when I am expanding this, I have to think about my properties. And remember, we have the multiplication, the product property. We have the division property, the quotient property. And then we have the power property, that Mario property. So which one do I have to use first when I'm expanding this logarithm? Yeah, that multiplication has to be expanded. And you guys told me 3 things are being multiplied together, which means I'm going to have 3 logarithms added together. So the first thing I do, and some of you already know the right answer and you're going to write it down in one step. That's awesome. I'm just not that good. So I have log of 5 plus log of a to the 3rd plus log of b to the 2nd. And why is this not done? Are you going to ask if you can skip that step? Yeah. Yep. Kyle says bring those exponents down. Was anyone thinking, like, as we were writing this, like, oh my gosh, I'm just going to write the 3 and the 2 down as I'm writing it? That's fine. That just means you're more advanced than me. Good for you. All right, so bring these exponents down using the power properties in front of their logarithms. So final answer, log 5, but you're going to have 3 log A's, and you have 2 log B's. There we go. Oh, that's ugly. Okay. You will have more space on your test. Promise. So I'm going to leave 5b for you to do. Let's look at 6a. 6a is a good time because you have 1, 2, 3 things in that logarithm, and I think you also have all 3 properties in that logarithm. So that 5a is done. Let's look at 6a. What do you use first? Which property are we going to... The quotient. Very good. So we have a natural log this time, and we're going to start by splitting it into the natural log of our numerator minus the natural log of our denominator. Now, I would claim that both of these logarithms are not done. They're not fully expanded. This guy has a 7 and an x to the 3rd inside of it. And this guy has a w to the 5th, which we can simplify a little bit more for expanding. All right, talk to me about this first logarithm. We need to split up the multiplication problem into natural log of 7 plus natural log of x to the 3rd. Can I skip a step, though? What else is going to happen? Yeah, the 3 is going to come down in front of that one. And then this last logarithm where you have subtract natural log of w to the 5th, the only thing you had to worry about for properties was bringing that 5 down. So I did skip a few steps in there, which hopefully some of you are getting to the point where you can start skipping some steps. I don't know if your first test is the time to do it, but you know, whatever. Give it a whirl. There's no harm in showing all the steps, guys. All right. Issues on that one? Okay. All right. Let's look at 7a. So we're going to back all that up and go and collapse them back together, or condense them. So our last step was to bring exponents down. That means my first step to put it back together is to put exponents back. Anybody here used to be an exponent? Yeah, this, not the 6. No. This 2. Anybody else? This 3. Good. And what's my final answer going to look like? Yep, common log and then some stuff. If you already know what it is, go ahead and put it down, but I'm not that good. So, all right, so log 6. This is now log of x squared. And this is now log of y to the 3rd. Okay, now I think I'm ready to collapse this down to one logarithm, because all of them are plus logs, which means they all get, the inside stuff gets multiplied together. So what would it look like if you tried to multiply all these pieces together? 6, x to the 3rd, and, oh, that's squared. My bad. Squared. Ugh, can't read that. Try again. 6x to the 2nd, y to the 3rd. There we go. So like I said, some of you, like, you could go from point 1 to the final answer. That's awesome. So maybe try that on the next one yourself. But we're going to do 8a together. Be careful on 8a because I think you have all 3 properties, so watch out. Any exponents need to go back up? We're on 8a right now. Yep, the 4 needs to go back up, and the 3 needs to go back up. So we now have natural log of x to the 4th plus natural log of y to the 3rd minus natural log of w. And again, some of you feel very comfortable collapsing right down to the final logarithm. And what I might suggest you do when you guys are taking the test is at the bottom of your workspace, just give yourself like a little template for what you know your answer should look like at the end. It's going to be natural log and then a bunch of weird stuff. So if you can get there now, awesome. Otherwise, we're going to take it in stages. So let's collapse the first 2 together here. When I do natural log plus natural log, I'm supposed to multiply these together. So this is now the natural log of x to the 4th, y to the 3rd. Good. But we still have a subtraction of natural log of w. Okay, now I'm ready to collapse down. What happens when it's log minus log? Quotient. So this guy is our numerator. And then the w is now in our denominator. There we go. So remember, any log that's being subtracted means that that's the part of the denominator of your fraction. So I'm just looking ahead to 8b. How many things are going to be in your denominator? 2 things. So watch out for that one. Alrighty. Questions so far? You don't get 8b? Say it again, Alex. Just b? Okay. Since these are both things subtracted, that means both of these things are going to be our denominator piece. So this is a little harder than what's on your test. Your test is more like this one. I know it's going to be log. And if you know that any subtractions are going to end up in your denominator, can we just go ahead and put them down there now? You see where I'm going with that one? What's going to be in your denominator? This will be b to the 5th, good. And this will be c to the, there you go. And then your numerator is little old a. Yep. I said I wasn't going to do that, and look what I just did. You're welcome. Quick, do another one. All right. What, dear? I'm sorry? Well, think of it this way. If we factor the subtraction out of it, it would be like 5 log b plus 3 log c. So they are being multiplied together in the denominator. That's what's happening. They distributed the subtraction of both. Sneaky, huh? We don't see too many of those, but it's good to know for our SAT prep. Good questions. Okay. All right. So, brand new stuff. We are solving exponentials, and we're going to solve logarithms in a minute. They're 2 separate skills, so they get 2 separate scores. So, you have a choice on number 9. Oh, this is supposed to say 9b, by the way. Sorry. It's b. For 9a, if you didn't remember to look for this, that's fine, but 9a does have a baby base option. Do you see a common base between a 7 and a 343? Yeah, it is a 7. So, 7 to what power is 343?
I'm gonna have to go with 7.
No, it's too big.
I'm gonna have to go with 5.
Too big.
3.
3. This is really 7 to the 3rd power. So, if 7 to the 2x minus 5 equals 7 to the 3, we got set them equal. What'd you say, Spain? I'm sorry. Yeah, well, they're kind of like negligible. We don't have to think about them anymore. So 2x minus 5 has to be the same thing as 3. Let's solve.
Can we just do that right off the bat?
You can, but the trick is you have to know to rewrite this as a 7. Yeah. And you know, guys, it always makes me nervous when you skip anything on your test, like as far as steps go, because if something goes wrong and you make a silly mistake, I can't follow what you did, and then I can't give you a decent score. So we get x equals 4. Now, that same question, if you guys didn't recognize, or maybe you don't like the baby base method, you could have done that a totally different way and still got the same answer. Do you remember your other option? Could apply a logarithm or a natural logarithm, yeah. So, if you don't want to think about 2 different method options, and you just say, I'm applying logarithms to every single question I see, that's fine. So, same question, you could have done, you want natural log or common log? That's the right answer. No, that's the wrong answer. All right, natural log. Natural log, we're going to use the Mario property. This guy comes down in front. And you get, I'm doing the same question, guys. You don't have to write it down. 2x minus 5 times the natural log of 7 gross equals the natural log of 343. And then you divide by natural log of 7, and guess what you're going to get? You're going to get 3, aren't you? Natural log of 343 divided by natural log of 7. It's 3 on your calculator. And now your math is going to match up, okay? Life is good.
Yeah, that's what I said.
Hit math enter.
How does it match up? If we got x equals 4.
Well, I didn't solve it yet. I still have 2x minus 5.
Yes, the answer's 4.
The answer will be 4, yeah. This divided over here is 3, is what I'm saying. All right. Add the 5 and divide by 2, yep. So at some point, your math does match. So it doesn't really matter how you do it. All right, guys. Now, from then on, you have to apply logarithms. And you have a choice, natural log or common log. Usually I say it doesn't matter, even though, I truly feel natural log's better. Unless I notice your base is something else. But let's look at 10a. Even Meyer will agree with me. Natural log is better on 10. You tell me why. There's indeed, yes. Fine. Oh, whatever. You guys are weird. Fine. Fine. Do what you want. She doesn't grade your test though.
Wow. You gonna blackmail us like that?
I am. It did get some new stickers. You're gonna earn yourself a sticker, man. Alright guys, natural log and E will cancel. That's why I chose natural log. Throwing that out there. Alright, so this is x minus 7 equals, I don't know what this is, something gross. Something. It's irrational, I don't know what it is. Can someone type it? 2.303. Thank you. And then we add 7 to both sides and get 9.303. Which, yes, common log people, you would have received the same answer after all your work.
So we should use the same.
Mine's better, though.
No, mine's better.
You're going to rue the day you want to get my logarithm choice. Alright, guys, let's talk about 11. It has some, yeah, we have some algebra manipulation to worry about first. Let's add the 7. Yep, now we have to divide by 4, I heard. So we have 5 to the x power equals 8. So now I have to apply a logarithm to both sides. You can apply any log you want. I'll go ahead and do the common log, you weird people. Alright, so the x comes down in front. Now this time, common log and 5, that does not cancel. Neither would natural though, so I don't really care. Alright, log 5 equals log 8. And this is why it doesn't matter, guys. When you're about to divide the log 5 to the other side, this is the same ratio had you done common log, or natural log, excuse me. So if you did natural log of 8 over natural log of 5 versus common log over common log, it doesn't matter. You still get the same gross decimal.
So it's just log 8 divided by log 5.
Yeah. And if this was like a no calculator exam on an SAT test, they might say this is your answer. Like they would have had that as your choice. Because unless you have a chart, you can't answer that. So, without a calculator. So, what is this, by the way? It's gross. Thank you. All right. Life is good. Moving on. Natural log is better. You're right. Natural log. All natural. Natural. 2 letters. All right, this is what we did yesterday, people. Let's try to catch up our people who are gone yesterday. How do we, quote, get rid of logarithms? Do you remember that fancy word? Exponentiate. Yes, you take a base of your choosing and you shove it underneath the problem and hoist the problem up. So, look what happens here. If you shove a 3 underneath the problem, boom, gone, boom, gone.
And then you set them equal, right?
I don't know. Alright, so then we have 9x minus 4 is now equal to 3x plus 20. And then we're going to solve that. Guys, for the sake of time, I'm going to assume you can solve a 2-step equation, and we're going to move on to 13. Oh, for Pete's sake, whoa, what? All right, number 13. I'm not ready to exponentiate yet, people. Subtract 4. So I have log base 6 of x minus 1 equals 2. So let's exponentiate with a 6. Good. So 6 to the log base 6 is going to cancel. What's going on over here? Very good. Yes, these cancel and x minus 1 drops down. But your friends are telling me this is 6 to the 2nd power now. That's a 36. So your answer is a 37. That wasn't too bad, right? Is there more?
One more.
Oh, good.
Natural log.
We got this. Oh my goodness, it's not isolated yet, guys. What are we going to do?
Add the 5 and
Divide by 12.
All right. Then I heard you guys tell me I have to divide by 4 still?
Yeah.
Good.
We have to add 5.
Yeah, we did that.
Okay. Divide by 4.
So I have natural log of x minus 2 equals 3. What am I supposed to exponentiate with if it's a natural log? Good, e. This is a base e. So the number e is going to get placed underneath the problem on each side. This side's going to cancel, and the x minus 2 drops down. But guys, over here, this is e to the 3rd power.
20.09. Oh my.
And then adding 2 to both sides, you get 22.086. Awesome. Woo! Look at us go. All right, that's your review. Good luck tomorrow.
Oh, I'm past